Hello, so today we're going to be graphing linear inequalities, and I already have some notes up there, so I'm going to walk you through them. But let me give you a basic overview here. What's going to happen is when we graph these things, it'll be like on a coordinate plane, because we're going to have them in like a slope-intercept form, right? Like our y equals mx plus b, or standard form. So what we're going to have is maybe y, but instead of an equal sign, it'll be like a less than or equal to 3x minus 2. So if we have something like that, give or take. So you kind of have your dots, right? We're starting to make our line. Boop, 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 boop. I'm just making it real quick. It's probably not exact, but something like that, right? So we graph the inequality as if it were an equation, like we've been doing. Then decide if the boundary line is solid or dotted. Notice I boxed the word solid in a solid line, and I dotted around the dotted with dotted. Okay, they kind of look like dashes, but that's the idea there. So if it's an or equal to, we have a solid line there. If it were, let's say, just a less than symbol, then we would make a dotted line, which honestly looks more like a dashed line. Okay. So that part's new. And then we decide which side of the boundary has a true solution. I always say to pick 0. So pick 0, 0. It does say choose a random point. No, 0, 0 is the best. We talked about this. It cancels things out. Use the 0, 0. So we check here to see if it's true. So if we plug in our 0, 0, we have 0 less than, well, if we plug in 0 here, 3 times 0 is 0. 0 minus 2 leaves us with negative 2. Then we just see if that's true or false. 0 less than negative 2. No. So that can't be a solution, which means this is the side over here we are coloring on. This, yes, a coloring. Now, this doesn't look beautiful because it's on the internet. It's on the web page. But if you take the piece of paper and you use the pencil and you like lightly shade it, it looks very nice. It looks lovely. All right, so do that. And that's what we have. So over here, I'll talk you through this one. It's in slope-intercept form. So you graph, right, the negative 5. There's your negative 5 point, right? Down here, do negative 5. Then they use the slope 3 over 4. So in up 3 over 4, up 3 over 4, up 3 over 4, right? So we graph our line as usual. The symbol is greater than, which means there's no or equal to. So it's a dotted line. We can't touch it. Kind of like we have our closed and open circle. This is the way to do that in a single line here. So it's going to be a dashed line. Notice the dashes. Boop, 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 boop. Then we check to see if 0, 0 is a true or false solution. Okay, so they plugged in 0. Whoosh. They plugged in 0. Whoosh. 3/4 times 0 is 0. What's nice is you notice it cancels out, and it usually just leaves us with 0, our inequality symbol, and the y-intercept. So is 0 greater than negative 5? Why, yes, it is. That is true. So since 0 is a true statement, that's the side we color on. Fun fact, only for slope-intercept form. Doesn't work for standard, but only for slope-intercept form. See how it's y is greater than this over here? So if it's in this form, if it's greater than that line, we're going to color greater than the line. See how it's above the line? It does not work over here, but it works for slope-intercept form. Awesome. So you could convert this into slope-intercept form and graph it the same way, but I'm going to talk through how to graph standard form. Here we go. So we have our 3x minus 4y is greater than or equal to 12. This is standard form. We talked about covering and solving, right? Plug in 0 for one, find your y-intercept. Plug in 0 for the other, find your x-intercept. So they wrote out that here. So here they plugged in 0 for y to find the x-intercept. So they'd end up with, like, this would be like gone. So we'd have 12 divided by 3 leaves us with 4 as our x-intercept. See how they got the 4 there? So we come over here, and on our x-intercept, whoosh, there's our first dot. Okay, next one. All right, so then they plug in 0 for x, solve for y, and then like 3 times 0 is 0, which kind of disappears. So we have 12 divided by negative 4, which leaves us as negative 3 for our y-intercept. So we plot our negative 3 for our y-intercept. Boom. From there, You can even see the slope up 1, 2, 3 over 1, 2, 3, 4, up 3 over 4, up 3 over 4. Okay, so you can connect your line. Now notice it's a solid line because dun, 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 that has that or equal to line underneath, so it's a solid line. Remember back here it was the dotted line. Oh, I should have done that. That would have been nice. Okay. Then we check 0, 0. So this time that little greater than trick won't work. We plug in 0. What's nice about 0, plugging 0, 0 in and checking the origin point with standard form, everything to the left cancels out. So we're just asking, is 0 greater than or equal to 12? No. 0 is not greater than or equal to 12. See how it's false? Which means if that's false, nothing over here is a solution. Everything down here is a solution. So color it lightly. See how it's like shaded nicely in blue? That's what you should be going for. Nice light shading. Because every single of these ordered pairs can be substituted in here and make the inequality true. On the next page, we're going to look at our graph here with those dots. So we are deciding if each of the following points are a part of the solution set. And then how you decided. Okay, so we're going to write yes or no and why we know this. Okay, here we go. So this first point is 0, 0. So here is our 0, 0. Is this a part of our solution set? No, no it is not. Why is it not a part of the solution set? Oh, great question. Oh, I can type this. Yes. I mean, no is our answer, but yes, I can type it. Okay. For no, it's not a solution because it's not in the shaded area. It's way over here. This is obviously a boundary line that says just from here and above, nothing below. So no, it is not in the shaded region. I think I spelled that right. Oh, look, it's decently nice. Cool. Okay, next one is 7, 2. So we go over to 7, up 2. This one. Is it a solution? Yes. Yes, it is. It's on the solid line. So it's like a closed dot. It is or equal to that. So that is true. It's part of the solution set. So this one is a yes. It is on the solid line. That is key. That's key. Solid line. Good. And 6, 8 has to be the other one that's floating out here in the shade. If it's in the shade, is it a part of the solution set? Yes. Yes, it is. It's in the shaded region. You could put shaded area. You can do that. Sure. Nicer. So you don't have to do shaded region. You can put shaded area. It's a few less letters. All right. I'm going to have you... No, I don't want to have you try this one on your own because there's something tricky. How about I do the one that's tricky and I'll have you do the easy ones. Okay. The trickiest one is this 2, 7. Is that a 7? 2, 7? Yes, 2, 7. So this one, is it a part of the solution set? The answer is no. Because it's on that dotted line. The dotted line is an open circle. It's like we can't touch it. So we cannot have an ordered pair on the line be a part of the solution set. So no. It is on the, you put because. Because it's on the dotted line, it is not a part of our solution. We can't touch it. All right. I'm going to have you do 0, 0 and negative 8, 8 on your own. I think you got this. Okay, here we go. Number 3. Is the point 1, 2 a solution to the inequality? Here's how we check. We substitute it in and solve. So as we can see here, okay, I'm going to draw this time. This is our x coordinate. This is our y coordinate. So we're going to substitute in x, which is 1, and y, which is 2, and we solve. Negative 5 plus, oh, sorry, negative 5 times 1. Don't want to make a mistake like last time. Let me know if I do. Thank you for those who let me know that I made a mistake. Okay. Negative 3 greater than 8. Okay, then we check. Is negative 3 greater than 8? No. So if this is false, right, as we can clearly see, then is the point 1, 2 a solution to the inequality? No, it is not a solution. No, not a solution. Let's write that. Beautiful. No, capitalize. You want to be fancy. To the inequality. Shall we? Oh, look at that. That's nice. That's nice. Oh, punctuation. Done. Okay. All right. I might shorten up my answers for the future ones. Okay. Okay. So here we go. Next. Is the point 9, 5 a solution to the inequality? Well, again, we substitute in and solve. So if this is x and this is y, okay, we put 5 in for y greater than or equal to negative 1/3 times x, which is 9, plus 8. All right, cool. We make 9 look like a fraction, then we can multiply straight across. Or I'm going to simplify early. 3 and 9 can both divide by 3. That gives me 1. That gives me 3. We end up with a negative 3 plus 8. Cool. Is 5 greater than or equal to 5? Yes. Because it's that or equal to underneath, right? Solid line, it's good. Dotted line, no. So yes. Because that is true, and I'm going to write the word true in just a moment. Yes, it is a solution. Look at us writing SBEC style answers. Beautiful. Like a full sentence. All right, and this is because it's true. All right, so see, if it's false, no. True, yes. All right, I'm gonna have you do 5 and 6 on your own. Let me know if you have questions in class. So try it out. Ask me questions. All right, here we go, number 7. This time we're going to graph it. So here we go. We're jumping in. We're graphing. So we start as per usual with starting at our y-intercept of positive 1. This is where we begin, right? So we go up to 1. We put a dot. Okay. Then we use our slope 1, 2. It's our rise over run. So we're going to go up 1 over 2, up 1 over 2, up 1 over 2, continuing and continuing and continuing the other direction. That way it's beautiful on both sides because, well, we can. All right, good. Now, notice I did not connect the lines yet. We got to check. Look right there. Is there the or equal to sign? No, so it's a dotted line. If you've already connected, erase. Here we go. So it's a dotted line, which, okay, honestly looks a little bit more dashed. Sometimes when I put my first point, I will look ahead and see it. And then as I do my slope, I kind of go up 1 over 2, and then I make a little dash. Just a thought if you wanted to. We still have arrows because that dashed line continues on and on and on and on and on and on and on in both directions. My other hand was showing too, but it was off the screen. Sorry. Okay. Then we have to check and see which side we are shading on. So for the shading, I like to check 0, 0, this point right here, okay? So we're going to check with 0, 0. How we do that? Well, we substitute in 0, 0, and we solve. So we have 0 less, 0 less than 1/2 times 0, which again, you don't technically have to write because if you can see that when we substituted 0, 0 in for this equation up here, we're going to end up with 0 less than 1. How? 1/2 times 0, 0. 0 plus 1, 1. Okay. So pretty much it gets rid of this term here. So we're left with our y-intercept. Is 0 less than 1? Yes, 0 is less than 1. So since that is true, this 0, 0 is a solution, which means that's part of the graph we shade. So this is where we are coloring. Again, your pencil will look much prettier than this scribbly's. So definitely use your pencil and make it glorious. Like the edge of the pencil, the side, shade it. Yes, do that. All right, and we're done graphing. So that's pretty much what we're doing here with these. Not so bad. So I'm going to do the next few. You're welcome to try it and then check. So for this one, I'm going to start at 3y because 3 is my y-intercept. Hilarious. Okay, -1 is our slope, so we're going down 1 over 1, down 1 over 1. Remember slope, dude. He's just gliding on down that slope. Okay. Sorry, that took so long. Okay. From here, is this a dotted or solid line? Solid. It's the or equal to. So what we're going to do is we are going to connect it with a beautiful straight line like we have been doing. And that looks pretty decent there. Good, good, good. Arrows, nice. Okay, here we go. The point we are checking for the shading. Show your work for the point you are checking. We're checking 0, 0 again. Why? Because as you notice, you could actually skip right down to here. I'm going to show the substitution just because there are notes. So we're checking 0, 0, this point right here. Okay, so we're going to check 0, 0. We have 0 for y greater than or equal to negative 0 plus 3. And as some of you are like, there's no such thing as negative 0. True, negative times 0. Technically, it's a negative 1 times 0, which is 0. And 0 plus 3 is 3. Okay, is 0 greater than or equal to 3? No. So since that is false, that is not a solution over here, which means we can't color this side, which means everything over here is a solution. If you want to check, you can always substitute in a random number and check and see what happens. And by a number, I mean a random ordered pair. So you can pick any point over here, substitute it in, it will give you a true answer. Yeah. Okay, now see how these are both set up in slope-intercept form? Remember I told you, see this one? See how it's a less than symbol and we colored less than the line? This one is a greater than symbol and we colored greater than or above the line. That does not work here. Unless you solve to get those into slope-intercept form, which you could do, it won't work. So watch out for that, but you can use it for slope-intercept form. All right, here we go. I'm going to graph. Now, I'm going to write it out a little bit differently here. So I'm going to write out for my x-intercept and y-intercept. So I'm going to put my x-intercept. Did I write anything in blue? Oh, yeah, I graphed in blue. Okay, I'm going to use purple. So, x-intercept. I'm going to solve for that here, and then I'm going to solve for my y-intercept. I'll use purple and pink over here. Okay, so I'm going to solve for each of these. All right, so for my x-intercept, I'm going to plug in 0 for y and solve for x. So that would be x minus 3 times 0 less than or equal to 6. Now, technically, we kind of technically solve like it's an equal sign, technically, because we're pretending to graph like it's an equal sign. We'll do our shading at the very end. So what's going to happen is our 0 disappears, right? It's negative 3 times 0 is 0, so that's going to be gone. We're left with x is equal to 6. So on our x-intercept, look at that. And for our y-intercept, we plug in 0 for x and solve for y. Now, some of you are like, don't we plug in the 0 at the same time? Well, that's when we are checking 0, 0 as an ordered pair. This is us finding our x and y-intercept, and I said it and did it. No. Man, see, sometimes when I talk about it, at least I fixed this mistake. Okay, so from here, 0 is just gone, because 0 plus or minus anything is itself, so we can just divide by negative 3, because 0 won't affect anything. It's kind of like equal to, technically. 6 divided by negative 3 is a negative 2. So our y-intercept is at negative 2. And then we can see from here to there, oh, it might be 1, 1, 2, 3, 1, 1, 2, 3. Oh, look at that, yeah. It's a 1, 3 slope. So our slope is 1/3. 1, 2, 3, 1, 2, 3. There, okay. So if you don't believe me, you could always solve, right? Subtract x from both sides. So this is optional. If you want, we'd end up with a negative 3y is less than or equal to negative x plus 6. If we divide both sides by a negative 3, our inequality symbol flips. So we are left with y greater than or equal to a positive 1/3 x. See how it's a 1 divided by 3, 1/3, secret 1. Secret. Negative divided by negative is a positive, and then 6 divided by negative 3 is a negative 2. What? Look, negative 2 is our y-intercept, 1/3 is our slope. So this is also an option if you don't like to find the intercepts. It's fine. All right, and then, is it dotted or solid? Solid, that's that or equal to line. So let's make a nice solid line there. Now we deal with our coloring. Okay, here we go. Here's our coloring. Here's our shading. So this is different than our intercepts. Notice we did our intercepts one at a time. This time we are checking the ordered pair 0, 0. So we plug in 0 for x, minus 3, plug in 0 for y, less than or equal to 6. We're going to see if it's true or false. We're going to see if we color this side of the line or not. Okay, 0 minus 0, because negative 3 times 0 is 0. It's going to be 0 less than or equal to 6. Is that true or false? 0 less than or equal to 6. True. Which means that is the side we color on. Okay, make it look better than that, okay? Beautiful shading. Again, if you solve it into slope-intercept form, look at that. Y is greater than or equal to this, so we color the greater than side. Just watch out if you multiply or divide by a negative, it does flip our inequality. That was in yesterday's notes. Okay, I'm going to have you... No, let's do it. We're going to do 10 and 11, and then we'll call it good. So you can try 10 and 11. Let's just skip 12 for now. Just skip it. Okay. You can always make a table is what they want you to do, and we're not going to do that at this point. Okay, here we go. So I'm going to find my y-intercept and my x-intercept again. So for my x-intercept, I have 4x plus, and my 2 times y is going to be a 0, right? Because we plug in 0 for y, solve for x. That is our x-intercept. And here we go. So we're going to end up with 4x is equal to 8. And then when we divide by 4, x is equal to 2. Okay, so on our x-axis, okay, next one, our y-intercept is when we plug in 0 for x and solve for y. I should have some background music on. That would be nice, maybe. Okay, so 4 times 0 is 0. We don't need that, so we're kind of left with 2y is equal to 8. And when we divide both sides by 2, we have y is equal to 4. Okay, cool. So on our y-axis, boom, 4. There it is. And then we can find our slope from there. Okay. 1, 2, 3, 4 over 1, 2. Oh, it's a negative slope, actually. Look at that. Down 2 over 1. Down 2 over 1. So it's a negative 2 slope. Oh, my face is in the way. Yeah. Okay, next. Is it a dotted or solid line? Well, that tells us right there that it is a dotted line. There is no or equal to. We cannot touch this line. We can get exponentially close, but we won't be able to touch it. Okay. Well, if exponential is the right word there. Moving on. Here we go. We got our arrows at the end. Now we just check 0, 0 to see if it works. Okay, we're checking 0, 0. So we're going to check this point. If it's a solution, that's where we color. Now again, you could technically pick any random point. You can even pick like 3/4 and 1/2, but who wants to work with fractions? Okay, so we have 4 times x is 0, close it, plus 2 times y is 0. We're checking the ordered pair this time and seeing if it's true or false to see which side we shade on. What's going to happen is we're going to end up with 0 plus 0, which is just 0. So we're going to end up with 0 is greater than 8. Is 0 greater than 8? No. So this is false. So since this is false, we do not color 0, 0. 0, 0 shall not be colored. We're coloring the other side. There we go. Okay. Lovely. All right, remember we're doing 11 and not 12. Here, let me just cover that with my face. Ah! Okay. Here we go. Final problem together for our notes. I think that's it, right? Yes, okay, good. And then you're done. We're going to start, well, look, slope-intercept form. We're going to start at -6. So we're going to go down to -6 on our y-axis. Boom, that's where we start. And then we use our slope, -2/5. So we're going down to 1, 2, 3, 4, 5. Down to 1, 2, 3, 4, 5. And we get the other side up to 1, 2, 3, 4, 5. And we go up 2 over 5. Okay, Then, is it dotted or solid? Whoosh. No or equal to sign, so it is a dashed line. All right, from here, we're going to check 0, 0 to see which side we shaded on. So remember, our intercepts for our standard form up here, these x and y intercepts are only to help graph standard form. So, or you could convert to a slope intercept. You have options, whatever you want. All right, so we're checking 0, 0. So we plug in 0 for y less than -2/5. Whoa, my handwriting, it's obviously time to go. -6. Okay, here we go. So we have 0 less than -2/5 times 0 is 0. And 0 minus 6 will leave us with -6. Is 0 less than -6? No. You can also see, look, it's a less than sign. Don't we color less than the symbol? Yes, that's true. So since this is false, 0, 0 is not a solution, so we cannot color this side. We color this side of the line, the other side. All right, get ready to practice and shade and color in class next class. Here we go. Oh, and make sure to catch up on your other classwork stuff. Monday's a good day to do that as well. I'll be on my Zoom, 9:15, if you have any questions. Bye.